Before proceeding, so I will introduce today's expert, the first session experts, Professor K. Srinivas Reddy. Professor K. Srinivas Reddy obtained his PhD from IIT Delhi in energy studies in 1999. Then he joined NIT Warangal in June 20 in 1999. After a service of about 4 years at NIT Warangal, he joined IIT Madras in April 2003 as an assistant professor. Presently, Dr. Reddy is a professor of mechanical engineering at IIT Madras, and he is also honorary professor at the University of Exeter, UK. He also served as an adjunct professor at Sri CSIR, Chennai. Professor Reddy is a fellow of National Academy of Engineering, fellow of the World Society of Sustainable Energy Technology, and fellow of International Society of Energy, Environment and Sustainability. He is specialized in renewable energy with special research interest on concentrating solar power, energy efficiency, and environment. He has 10 patent applications and more than 350 publications with more than 11,000 citations. His co-authored book on sustainable energy and the environment, a clean technology approach, and the solar thermal desalination technology for portable water, published by Springer, and book chapter on solar energy system are popular among energy and environmental community. Professor Reddy is actively involved in implementation of solar thermal technology for power generation and process heat applications. He has secured research funding of about USD 15 million as a principal investigator of more than 30 research projects related to solar energy, energy and environment, and heat transfer areas supported by the various Indian and foreign funding agencies. His work on estimation of thermal conductivity and thermophysical properties and characterization of energy engineering materials significantly benefited the industrial associates for development of energy efficient thermal insulation materials. Dr. Reddy received several awards such as WSS ET Innovation Award, Sustainability Champion Award, and Mid-Career Level Institute Research and Development Award, Shri J.C. Bose Patent Award, and Bhagya Lakshmi and Krishna Iyer Award. He also won Career Award for Young Teacher from AICTE. He served as member of Board of Governors IIT Tirupati during 2018 to 2023. He is an expert committee member in various selection review committees and visitor nominee for IITs, NITs. He supervised over 200 research students. He organized several national international workshops on advanced renewable energy technology. Sir, we welcome you.
Thank you very much. Thank you. Can you hear me?
So now I request Professor Reddy to please deliver your lecture.
Can you see my slides? No?
No, sir.
No,
Please
no,
share
sir.
it again, sir. Please share again. It's actually the starting. It came again. It went down.
No?
Yes, sir. Perfect, sir.
Now it's fine.
Here you can see these slides.
Yes,
Yeah.
sir.
Yes, yes.
So because once I go into the slideshow mode, I cannot see my
Okay,
presentation.
okay.
So I think why it's coming like this. Okay, just 1 minute. Now you can see here.
Yeah. Yes, sir. Fine. Fine. Fine.
Yes, sir. Fine, sir.
Thank you very much. At the outset, good evening to all of you. At the outset, I thank the organizers, particularly Professor Srinivas, for inviting me to give a talk in this FDP program. I will try to give some brief glimpses. By 7:30 I can close it, isn't it? Or before?
Yes, sir. Yes, sir. 7:30.
Okay. So I will give glimpses of the poly generation technologies, mainly for reliable energy supply. I'll give various technologies developed at IIT Madras, and also we have done one or two major projects through poly generation mode. I will give one case study as a part of this presentation. So before that, I'll give an introduction to the energy poly generation. What exactly is the poly generation mean? And as you know that there are broadly these two types of energy sources. One is a celestial or income energy. The other, that means this income energy source means the energy which is reaching from the outer space to the earth, and which includes solar, lunar energies, electromagnetic, gravitational, particle energy from stars, planets, and the moon, and also potential energy of meteorites entering into the Earth's atmosphere. The meaning of this is whatever energy which comes from the outer space is referred as a celestial energy. And though there are several forms of celestial energy, but the most important one is solar and lunar energies. Of course, lunar energy is in the indirect form. And the capital energies, which is already exist in and on the earth, mainly in the form of fossil fuels. So if we classify these energy sources into reserves, mainly renewables, fossils, and nuclear. But these energy sources further transformed into a secondary form of energy source, which you can see the energy carriers. This is a energy system hierarchy, and you have fossil fuels like coal, oil, gas, and then biomass you have, and then renewables and nuclear, and they are transformed into energy carriers as a form of electricity or liquid fuels, and subsequently they are used as for the consumer choice, either in the building side or this. But here the greenhouse emissions play an important role as far as the energy system hierarchy is concerned, because we are primarily dependent on fossil fuels. They will result in environmental problems. So if you look at the global energy potential here, the energy consumption is this world's energy consumption. It is being met by various energy sources like this, and their quantities are given here in respect to circles. So as we know that the fossil fuels you consume, then they extinct after some time. But if you look at this bigger circle, which has a huge potential to meet the requirement of this one, so therefore the solar energy can be a source which is more sustainable for meeting the world's energy demand. And if you look at the Earth in the night time from the space, it looks like this. Wherever it is highly illuminated places, they have a more energy demand and potential. There are less illumination, they are under energy poverty. And you look at that, there are several countries still under energy poverty with less access to the electricity, and their primary energy requirement is met by the biomass, because primary energy means mainly food processing and mainly cooking and other applications. So there are several million people do not have access to electricity, out of which 1.6 billion people have in this area here, some South Asia and Sub-Saharan Africa. Energy sustainability is very important, and most of the energy supply primarily on fossil fuels. As we consume fossil fuels, we have environmental degradation. Another important thing is these fossil fuels are highly unevenly distributed across the world. That means there are only few places you have more fossil fuel like oil, like Middle East and other countries like Russia and other countries. but whereas we have acute shortage of fossil fuel. So the technology which we use from imported technology like these cars, automobile, and they consume oil, which is foreign fuel, which we import, and our most of our foreign exchange goes for importing the oil. So what happens is, you have seen recent times there is a lot of geopolitical unrest, and that is significantly playing the supply chain of the fuels. As you know that there is a sanctions in the Middle East. Because of that, the oil supply has substantially impacted, and not only that, the prices highly, the oil mainly petroleum prices are highly volatile because of the geopolitical thing. So if any disruption create a supply chain, so therefore if India, since is a primarily dependent on supply, so therefore there is a huge problem with the supply. So therefore once the supply is stopped for that, then this kind of um, uh, systems are mainly these cars will land up into this condition, because energy sustainability, as there is a stoppage of fuel to the country, then obviously we have to go back to the original state. We land up. So energy sustainability is very important, and it is the earth, if you look at from the outer space, it looks like this, but this earth is getting polluted. It is enveloped by an atmosphere, and this atmosphere is getting polluted because of the excessive use of fossil fuel energy into this. So therefore we are literally imbalancing the atmosphere, and we are burning the atmosphere, and it's getting imbalanced. The entire earth planetary system is getting imbalanced because of excessive use of fossil fuels, and there is a atmospheric imbalance as far as the pollution concentration is concerned. So therefore any overload system is not good, because we are overloading the earth's atmosphere by emitting pollutants. So any overloaded system looks like this. So therefore it is important to take care of sustainable energy supply, and the resource sustainability is very important. So if you have resources there which are limited, and if you try to consume these resources, they will become empty or exhausted. So therefore it is important to keep this system resources sustainable, but if there is no technology, it is unsustainable. So therefore it is important to come up with a system technology to keep these resources for the future generation, and this technology is a sustainable technology, or renewable energy technologies, or solar technology. And when you know that the solar technologies are more sustainable, or renewable energies sustainable, but the energy consumption, the important, the future generation says that there's only one earth, we have to take care of this. Energy sustainability can be attained through several ways. One is energy efficiency, and a proper mix of energy sources, and make use of renewable energy technologies. So this the energy efficiency can be improved through a poly generation, because poly generation means you are producing many products with the same energy input. So eventually we are increasing the energy efficiency through cascading the energy utilization. That means the based on the grade of the application, energy application, then we are cascading these systems such a way that the higher energy requirement may met at higher levels, and lower same energy, once it is utilized in a particular stage, then you can go to the next stage and keep on till the end of that. See, if you have seen heat temperature scale. So what you are doing is you are cascading high temperature energy source to the lower energy so temperature application, and in the process you are distributing these sources at different levels. Eventually the every joule of energy is utilized in a more effective way. So the proper mix of these energy sources will create also an appropriate effectiveness, and renewable energy is a more cleaner fuel. So therefore, it is important to integrate three things: energy efficiency through poly generation, proper mix of energy sources, so that you will have a effectiveness as far as the energy efficiency is concerned. Ultimately, you use renewable energy sources which keep the environment more cleaner and more sustainable. So therefore, there are several barriers when you look at reliable energy supply. This energy supply, there are various parameters which influence reliable energy supply, like transportation bottlenecks, increase in energy demand, domestic unrest, energy investment, market deregulation, energy price volatility, technological developments, geopolitical instability, and energy imports. So here the primary objective is how do we attain energy security, because when a country is more dependent on foreign fuels, as you know that India is importing all forms of energy sources, like we are importing coal, we are importing gas, we are importing oil, we are importing nuclear energy. So therefore, when we are dependent on imports, it is very, very difficult to attain energy sustainability. Why? Because our energy security. Why? Because the energy security means it should give a continuous and uninterrupted availability of energy. So therefore, but there is a the security of supply is very important. It plays a crucial role in decision making, which is related to formulation of energy policy or strategy. But there are threats to this energy security because of natural causes or technology.
Hello, Professor. Voice is not coming. Professor, please unmute your voice.
I think somebody has muted. Hello?
Now it is coming, sir. I think.
No, but I think I have not done it. I think somebody from your end has done it.
Okay, I'll check, sir. We'll check.
Because I don't know, maybe organizer. I have not unmuted. But
No,
what
no.
till this slide you can hear me. No, there's no
Please share
problem.
it again, sir. Please share it again, because it's now it's energy sustainability is coming.
Okay. Is it okay?
Yes, sir. Energy sustainability is fine, sir.
Yeah.
Okay.
So till here you heard. Now I can hear. I hope
Yeah.
you can hear me now.
Yes.
Okay. So now, so the energy sustainability is because there is any geopolitical unrest that may lead to a disruption of the supply. That's why, and even if there is a waterways obstruction or sanctions and other problems create a problem. So therefore, we want to have energy security as far as the India is concerned. That energy security can happen only through renewable energy source, because it's your sun. Nobody can stop your sun's energy. Even if some other countries, Western countries, they wanted to stop that, they cannot it. And your wind, your biomass, your ocean, and all these are yours. So therefore, energy security can be attained only when you go for renewable energy technologies. So if you look at energy reserves and their availability for the India, so there are limited sources as far as mainly fossil fuels are concerned. So therefore, it is important to go with the renewable energy sources. So then we are looking at poly generation. What is the meaning of poly generation? Poly generation means, as you know, that producing more than 2 or 3 products, or even beyond that. So most important poly or cogeneration system is producing process heat and power. So if you look at the process heat and power generation applications, any heat which is below 260 degrees Celsius, which is more conducive for process heat applications. And power generation means any heat which is above 60 degrees Celsius, but you need power generation, a cycle or a heat engine. The heat engines you have already studied in your courses, that heat engine, any either it's a Rankine cycle, Brayton cycle, Stirling and hybrid cycles can be used. So now when we talk about poly generation, the poly generation, one part is how do we produce power. Power is one part, but apart from that, the heat which can be used for various other applications like heating, cooking, drying, and refrigeration, and so on. So therefore, there is a wide variety of industrial process heat applications with a different processes, and I have listed out here sterilization, pasteurization, drying, because we are now talking about dairy industries where you need multiple processes with cooling, heating, and other products, hydrolyzing, distillation, evaporation, washing. All these processes are involved, cleaning, polymerization. There are several processes in which you have a graded energy utilization. As we use graded energy into high temperature to low temperature in the process, you produce, if you produce different products, then it's called poly generation. And how do we attain this poly generation? Through solar systems, solar energy, as mentioned, that mainly for giving reliable supply. The solar energy is converted into heat from sun's radiation, and that device is called solar collector. The collector can be a simple flat plate collector or concentrating collector, but the heat which is absorbed by the collector needs to be transported for the process heat or power generation applications. So therefore, there is a working fluid which is circulated through these collectors to pick up the heat and give at appropriate location. Either it is in a cascaded like polygeneration mode or trigeneration, cogeneration. So you have a cogeneration, trigeneration, polygeneration. Cogeneration means producing two products, and trigeneration is three. And if you have more than three products, it's called polygeneration. So now this working fluid can be circulated in a closed loop mode. A closed loop mode here, that is called closed cycle or in a cycle mode. And the applications here, process heat or power. And but what happens is, in order to improve the reliability of solar energy, we can go for energy, thermal energy storage. So now thermal energy storage is gaining momentum to get that. And the applications for process heat poly generation condition is, you have a cooking and a refrigeration. This can be cascaded. We have done some of this cascading as a part of our poly generation. So now you have seen solar thermal collector technology. They can be a stationary or concentrating collectors, and based on stationary, they are low temperature. These are all mainly generally low temperature applications. This is for high temperature applications, and they are concentrating. They can be reflective or refractive, and most of these concentrating collectors need to be tracked along with the sun. So therefore, tracking requires either single axis or two axis tracking system, and the tracking system consists of sensors, drives, and controls. So they have to be effectively utilized to make most efficient concentrating collectors. And they have listed out here various concentrating collectors which are used for poly generation applications. So these are some of these, maybe single axis, two axis collectors. And the concentrating, because since poly generation requires high temperature heat, because low temperature heat is already low, you cannot use for producing multiple products. So effectively, you need to go for high temperature heat. The high temperature heat can be attained only through concentrating collectors. There are four technologies have reached to the maturity: solar parabolic trough, the solar power tower, linear Fresnel reflector, solar dish. So these are point focusing and line focusing collectors with two or single axis tracking systems. As a part of our research and development, our approach is a 4D approach. design, development, demonstration, and deployment. So we have developed various technologies for power generation. For some of them are power generation, some of them are cogeneration, and some of them are even single generation, mainly for decarbonizing the energy scenario. So ultimately, we need to go for net energy, net zero emissions or net zero energy scenario. So India has targeted to achieve net zero energy scenario by 2070. So we have almost another 65, almost 50, 45 years now. So eventually we have to make it net zero concept. As a part of that, we developed several technologies. I have listed out here some of these technologies, which I will go in detail. This is, as I mentioned, that our approach is a 4D approach: design, development, demonstration, and deployment. So you start a design of a solar collector, and then you develop for performance improvement and reliability, and demonstrate to make it more field study, and then ultimately you take it to the deployment for when you implement it in the field. So this 4D approach is very important for any technology development, implementation, and dissemination. So diffusion of technology into the field. Though, so therefore these play an important role, and you have seen our group here. And the another view of these technologies is this: we have a concentrating collectors, line focusing collectors, and they are essentially produce very high temperature heat, which can be cascaded in different applications. And I have given you the temperature limits in some of these systems. 640 degrees Celsius is obtained here, and where again desalination is another concept where you can use that, and then parabolic trough collectors where you get 350, much lower than the concentrating color, the point focus concentrating collectors. So then you have a concentrating photovoltaics, maybe for trigeneration or polygeneration concept. This is another view of our technologies where you can see that it is a demonstration scale, and the people are standing here, so therefore they can be taken into the field directly and implement it. There's another view. So for poly generation, you have ETC systems, then integrated collector storage system, mainly team based, and then you have other applications you can see here. So when we go for poly generation concept, the concentrating technologies need to be perfected, because the reliability is very important and the cost is another important factor. So most of these solar systems, they are outdoor conditions, and they have to withstand in terms of performance of heat production, or in terms of the performance as far as the structural stability is concerned. So therefore they should be structurally stable and give a good output. So for that, and it also should have a lighter in weight when we implement in rooftop applications. So therefore, if you want to make lighter, reliable, and cost effective any solar technology, we need to go for advanced engineering materials. So some of these materials are nano engineering systems. So solar concentrating solar system broadly consists of 3 components: concentrator, support structure and tracking, and receivers. So they play an individual role as far as the CSP performance improvement analysis is concerned. How do we increase performance here? We have to go for structural strength, because if a solar system is installed in an open environment, and if there is a gusty and wind conditions, and if they cannot withstand that, then there is no meaning of designing of a solar system. So therefore, it has to be structurally strong, and it should also have thermal capability to receive energy as well as to store it, and the concentrators and critical heat flux, heat transfer coefficients, and mainly durability, absorption of the receiver play important role, and for which we need to go for nano engineering, so that they will become. So any solar collector consists of broadly 3 One, we have receiver, the concentrator, and then support structure and tracking. All these combination is called solar collector. So solar concentrating collector. So here you see one such system where we can concentrate solar energy directly into the receiver, where we can produce high temperature heat, and this is subsequently cascaded into poly generation system. And apart from for running this, there are uh, other technologies like see, this is a photovoltaic with the tracking system, which is a simple, because here in this case it has to be tracked two axes here. One is elevation tracking, the other one is azimuth tracking. So this tracking, as I mentioned, that tracking and support structure, the tracking cost should not be very high, because if this tracking cost is very high, whatever additional input which you get out of these characters will be subcritical or sub-economical. So therefore, the tracking system should be most efficient, because it should track 2 milliradians accuracy. But not only tracking, but also it should not require parasitic power, because if it requires large amount of power for tracking, then whatever the output which you get out of the system will become negligible, or there's no meaning of implementing tracking. So therefore, tracking system should be effective such a way that it will give, it should be reliable, and it should also consume less energy, less parasitic power. So therefore, we need to develop an effective tracking system here. And though we tested with flat plate collector, this can also be used for concentrating collector. What happens here is the accuracy of the concentration of collectors is very high, and not only that, it will be the cost is also much lower. So we developed that, and this is a cogeneration system. Mainly it's a solar concentrating photovoltaic system with the active cooling, and you can see here, this is the solar radiation from the sun. It comes here and reflects onto the receiver, where this is the receiver which is placed here. So this receiver is integrated with solar PV concentrating PV system, but the PV system performance will improve when the solar radiation which falling on the system is higher. But when you allow the solar radiation at a higher level, the panels will also get heated up, because whatever the conversion efficiency that will come in, the rest is a heat rejection into the atmosphere. So therefore, the heat rejection can be done effectively when you place this photovoltaic system, triple junction photovoltaic system. You need to concentrate solar energy onto the photovoltaic, but simultaneously you need to cool it. So that is why it produces electricity of 725 kilowatts, and also produce heat. It's a cogeneration. It also produces almost 2 times higher the heat. So this heat can be used for low temperature applications, and but still electricity is used. It's a one type of cogeneration system. This can also be used for trigeneration. Why? Because this heat which is coming out from this can also be used water production. So you can take heat, produce water. Water means through desalination route, or through drying of foods, or cooking applications, various other applications when you go for trigeneration mode. This I have already shown, because the tracking system plays an important role in trigeneration, because this improves about more than 20% of the parasitic power there. And this also, see here, the solar cells is a triple junction solar cell, and that requires concentration. Not only that, it is a higher efficiency, more than 40%. So remaining 60% can be used for low temperature applications, where you have a polygeneration mode. So it can be a reflective type of concentrator, or refractive like lens. You can see here there is a solar cells placed here. It reflects, the refracts radiation into that. And this solar cell is a triple junction solar cell, and which is the most efficient, about 55%, and so on. And another important polygeneration mode is producing water. How do we produce water by solar energy? So therefore, that is mainly for through process heat. I have already mentioned there is a wide range of process heat applications. Any heat which is less than 260 degrees is referred as a uh, process heat, and this process heat can be used to produce potable water. We have developed three-dimensional elliptical hyperbolic concentrators that you can see here. This is a hyperbolic, and then this is an ellipse here on the top view, and the solar radiation is reflected here, and then it's absorbed, and the heat which is taken here is to produce the desalinated water. And we have studied complete from 4D approach through 4D. So we have designed, we have developed it, we have demonstrated. And if you look at that, this is a this structure is hyperbolic, and this is an elliptical here. And whatever rays come in should necessarily go to the bottom, and so that it gets captured in a cavity way. And another important poly generation approach is how to produce heat for wastewater treatment. So effluent treatment through there is a solar technology which you can see the solar collector field is used to produce heat, and that heat is given to the wastewater, and ultimately you will produce cleaner water from wastewater treatment. But the requirement is a different way. You can see here, this is a prototype we installed in a textile industry in Tirupur, and where the effluent is treated through this. It's a wind-aided cross-flow evaporator for urban areas. Now, poly generation is very important here. How do we integrate various renewable energy sources in a poly generation mode? This is one of our projects which is funded by UK, India, and mainly to improve the design concept of integrated renewable energy system, mainly for various applications. Solar and biomass is integrated to bio CPV, means solar bio energy based photovoltaic system, and which produces both heat, gas, cooking gas, and electricity and water. And it is mainly aimed to cater the needs of very poor people or deprived people here. So it is located in Vishwabharati University, which is Rabindranath Tagore's place, and it is a bit away from here. So this is the location here where you can see. And this here it involves a poly generation concept. Here you produce heat, and that through that heat you will produce electricity through a concentrating photovoltaic, and the heat which comes out of this can be used for various application, and also biomass integrated AD digester. This is a anaerobic digestion system where the biomass is produced through biogas, and that biogas is used to drive the engine, which is which caters the needs of people. So therefore, if there is an excess energy, you can go for hydrogen product. As you know that hydrogen is a energy carriers, and now it's gaining momentum. Hydrogen economy is a major challenge now, and to produce hydrogen. And a typical bio CPV system consists of this. There is a CPV system, there is a anaerobic digester, and the food waste and the waste which is produced in IIT can be fed to the anaerobic digester. And once that digester is, it produces biogas, and then you integrate with the in fact we modified a petrol generator into biogas generator, where you need to tune the mainly spark plug or the associated mechanisms. So this is Sun energy. This is a biomass, and it's integrated for poly generation to produce electricity, to produce the gas, and produce the water. So water, electricity, and biomass, then it is referred as a poly generation system. And if you look at the statistics of specifications of the bio CPV system, as I mentioned, that a poly generation should produce many products. So one important product is the electricity from here, and another product here is hydrogen. here, and that is used for enriching the gas, and then there is a cooking gas here. So the products is hydrogen, cooking gas, electricity. Apart from that, there's a water also. So it's a poly generation system, and it's an integrated. I think I've given you the energy distribution across various components, which is a biogas integrated system. So therefore we even how to storage these here. See, actually now if you look at this system, we have a hydrogen, we have a cooking gas, we have electricity, and we have a cold storage unit also. See, so cold, heat, gas, and hydrogen, electricity, all these is cascaded or in the same system, which produce in a poly generation mode many products here. And in fact we also used water production also this, but it's not listed here. So you can produce electricity, water, cold, then you can produce heat, then hydrogen, then cooking gas, and of course the water lifting. Water comes from this, of course water is a feedstock to the hydrogen and so on. So that is called poly generation system. Now, how do we design for high concentration system for this? So here this CPV module, which is the source of both heat and electricity, and this heat is used in a cascaded way for poly generation applications, whereas electricity is powered, the excess electricity is used to power various auxiliary systems here. So the solar energy is concentrated into a PV module, which is concentrated PV, and where it consists of triple junction solar cells. And you can see here we will get heat as well as the sorry, not this. This is power. So this is a hydraulic system is to track this, but power, both it's two products are produced. Electricity can be used for any other applications, but whereas this heat, which is recovered from the thermal management route, we can use various applications, desalination or air conditioning, chilled water, and all these applications can be used. So initially, any design, in 4D approach, you need to design through flux distribution. And as you know that solar system is an optical, thermal, and structural component. Any solar system, it should be optically perfect. It should have a good optical properties. Then second, it should also withstand thermal, or it should produce heat. So therefore it's a thermal component. And finally, it should be stable when there is a windy or gusty conditions, because in our experience we have seen during the cyclone conditions, sometimes these solar systems flown off. But I think so far we have not experienced much, only once it happened, because that is also because of the student mistake, because he has not kept the solar tracking solar system in a stow position or parking position, because in the night time when you don't use the energy, when it is subjected to high wind conditions, you need to keep it in a minimum loading conditions. So if sometimes students may forget, and when they forget, there was a couple of years ago very severe cyclone in Chennai that created a problem to the structure. So therefore it has to be structurally stable. And then you see that there are various solar cells are connected in series parallel to get the required current voltage characteristics. And you have a secondary concentrator when you want to get 1,000 suns. That means you are concentrating one sun into 1,000 times by various concentrators. So therefore you have these concentrators here. And then waste heat recovery is also another important challenging. So a heat exchanger is designed to remove the heat from that and subsequently use for other applications. The thermophysical properties are electrical characteristics of solar cells shown here. And if you look at the another view how it works in a 3-dimensional, it is this one. It's electric motor which drives the solar. These are some of the fabrication methods where the solar cell fabrication is a very challenging, and when you concentrate solar energy, the solar cells area is very smaller. So therefore, the with a small area, we need to recover maximum amount of heat. This is such a thing, and you can see I have already shown this. These are my lab, and you can see this. Systems which are used for process heat, and mainly see backside of that I think we have an air conditioning system. I think you will not see here, but I'll show. So how the flux is distributed at the focal plane, because here you need to measure the flux distribution and taking it to the waste heat recovery unit and so on. So because the heat can be used, and these are some of these challenges when you do that. Sometimes they can be burned off, and you can see essentially the flux distribution here, how effective it is here. And then the pipelines which are used for poly generation application, and you can see here how the heat and thermal management. So there is a heat exchanger designed for managing the thermal here, and this is a PVC cooling kit where you can recover heat and use it for cooling applications here. So this is one such systems. So therefore, we can also go with the integration of in a poly generation. You can see here with the different inputs. So there is a thermal loads are there. There is a electrical loads here. There is a hydrogen storage, and then you have a biogas. This is another product. This is a 1, 2, 3, and of course the electrical. 4 products are coupled in a single poly generation system to produce electricity, hydrogen, heat, energy storage, and also thermal load conditions. So the biogas is used for integrated with solar. So generally biogas is referred as a carbon neutral fuel. So there are we use this because we have to convert when we integrate solar CPVT with the biogas for biogas production, as well as it is used to burn in this one. So this in this balloons it is collected, or pillows collected and applied, and then this engine is driven by biogas. So you can see the load is applied here, and the biogas is there, and this CPV and biomass for poly generation applications. This is the engine which test rig which can produce electricity through biogas one, and there is a waste heat recovery. That heat can also be used through exhaust route, and there are the other views of that experimental setup. And these are the PV panels, mainly when we integrate with the biomass system, because biomass sometimes unreliable, or the vice versa. The solar system is not reliable when you operate at a large scale operations. So here battery inverters and other systems here, and the biogas production is another important for with energy storage batteries. And the performance characteristics of both biogas as well as the solar system has been studied, and here biogas is represented with the flow rates. As we increase the flow rate from 414 LPM, that's liters per you can operate with 14 LPM and up to 20-25 LPM flow rates here, and we can see that how the electrical load plays an important role here in this case. So LPG biogas mixing is also done, and it's so there is a comprehensive biogas analysis has been carried out, and then you have to use both of them in an integrated fashion. So here the bio-CPV concept is used for reliable energy supply. I'm coming to end of this. So then in a poly generation mode, which can bridge the urban-rural energy requirements. And so therefore, the poly generation, cooking gas, heat, electricity, water, coal, and hydrogen, all of them are produced in a single demonstration plant, and it's a comprehensive integration of integrated renewable energy through ICCM, integration, control, communication, and metering mode for a rural community, so that we can give uninterrupted power supply in uninterrupted gas, which is biogas, which is produced through biomass, and then cold storage, as well as the other which I have mentioned here, hydrogen and biogas enrichment. So therefore, the renewable energy system can also match the load demand conditions, and with a poly generation mode for sustainable applications. So with this, I thank you very much. As you know that the organizers have introduced about me. I am from IIT Madras, and IIT Madras is a more sustainable campus, and it's about 700 acres of campus, in which we have a lot of animals, lot of including human beings. So these we have 500 Ds, and all it's most sustainable. And this my friend who is looking to you seriously for questions. If you have any questions, please ask this person. I'll answer on the person's behalf. Thank you very much.
Thank you, Professor. Now I request the participants for if you have any questions, please.
We have some time, half an hour for 20 minutes. We can
Yes,
discuss.
yes, we can interact. Yes, it's fine.
Sir, good evening, sir.
Good evening. I can.
Sir, integration of biomass and CPV system is there, no, sir, in slide. Previous that one slide is missing, sir. Can you show that, sir?
Oh, something is missing. You can see. Which one?
Integration of biomass and CPV system.
Here?
No, sir.
This one?
Integration of biomass and CPV system.
This one?
No, sir. Integration.
Okay, integration. I will go. Just 1 minute. You tell me. This one?
Yes, sir.
So you want me to explain?
Can you explain this, sir?
Yeah, okay. I'll explain this system here. See, you know that CPV. CPV means concentrating photovoltaics. As
Yes,
you
sir.
know, normal photovoltaics have a less efficient, that silicon or single crystalline or polycrystalline solar cells. They have less efficiency in the order of 15%, maximum 20%, and now lab scale. But what happens is remaining 80% goes as heat from normal PV systems. But what happens is when you increase the solar radiation onto the cell, the efficiency increases. But what happens is simultaneously there is an increase in temperature of the cell. So one way, if you concentrate solar radiation onto cell, the performance will improve. But temperature also increase. So because of the temperature, again the efficiency drops. It's a contradicting. So therefore, one side you increase the solar radiation, the other side, because of the temperature, the efficiency drop will be there. So the better way is you concentrate solar radiation onto the PV, that is concentrating photovoltaics, but simultaneously you remove heat from the solar cells, so that the cells are operated at low temperature and will give a higher performance, which is close to 40 to 45%. And the heat which is recovered from the solar cell can be used for some other applications. That is a polygeneration or cogeneration applications. So the electricity which is now, if in this case you look at that, the electricity is coming from here. Just 1 minute, I'll take pen, pointer, pen. So this electricity is coming here, and the heat is coming, then that can be used for other applications. And this electricity is first stored in the battery, and then excess energy goes to the control, and then it goes to a rural. This is installed in a Vishwa Bharati, West Bengal, Vishwa Bharati University, in a tribal village, which this is about without any grid. It's a small village, and this electricity comes here. Excess electricity is used to split water into hydrogen, apart from the battery storage. And then this hydrogen is stored in this tank. And as you know that integration of biomass, this biomass is a heterogeneous biomass because any type of biomass is fed into the anaerobic digester, and our collaborators developed some microbes which can take care of a heterogeneous biomass, and which gives the higher output, and that is taken here. And the hydrogen is and the biogas is enriched with hydrogen, so that this high quality biogas is fed into the IC engine, that is a generator, which petrol engine is modified to take care of the biogas, enriched biogas, and this produces electricity, again it gives back. So this is a 24/7, because whenever there is a solar, it during the daytime you can directly gives, and then excess energy is stored in the battery, and parallelly, if there is no excess energy, you can operate in the evenings biogas. So it's a comprehensive integration of both biogas and CPV system to give 24 hours power. But apart from that, this excess biogas is stored. We have autonomy. The biogas can also be used to these villages as a cooking gas. We have given as a cooking gas to these people. So therefore, one cooking gas, and we also used for mobility applications also. So that's what the integration of biomass and CPV. I hope you understood.
Yes, sir. Thank you, sir.
Yeah, if you have any further thing, let me know. Yeah.
Hello, sir.
Yes, yes, yes.
I am Dr. Manish, working in CPET Jaipur. Sir, you have shown the slide of integration of biomass and CPV. So, what is the maximum capacity so far installed in the world or in India?
Integration of actually as far as the biogas integration for cogeneration, it can go even megawatt level, but what we installed was it's a small system of 10 kilowatt uninterrupted electricity, 10 kilowatt, and 3 days of cooking gas. So 260 houses, because the load I have not seen, some work is unpublished, so I have not shown. But the load, what happens is, load in order to meet the load profiles of the village, it gives uninterrupted power supply, as well as 3 days of autonomy for cooking gas.
One more question regarding on this only. The capacity PVC and biomass should be equal to run 24 hours.
Please repeat again. 24 hours.
See, PVC work only in the daylight time, during day. So for integration, if I want to use, so then the capacity of biomass should be equal.
They're not equal. What happens is, I'll tell you, we have taken this village, about 60 huts are there. And if you look at the load profile, biogas is used for cooking, and there are generally 2 times cooking happens, morning and afternoon. And if you look at the load during the daytime, there is no much load, except there is actually some health center and school, but in the daytime there is no electricity requirement. These are all small huts, so therefore there's no electricity requirement. Only electricity requirement is in the evening and night. So evening, if you look at from maybe somewhere 5:30 to 7 o'clock or 9 o'clock, you have a peak load conditions. In the peak load condition, solar is not available, whereas during the daytime, wherever that smaller loads, you can give it. So during the daytime, you produce electricity and store it in battery. I've shown you the battery case also. And during night time, you don't need lighting in the houses, only street lights. If you look at our load profile, only street lights, which is a smaller capacity. So it is like this. During the day time, the day loads are catered by solar, and when excess energy is there, it is stored in battery, or it is used to produce hydrogen, because hydrogen electrolyzer is there, and that hydrogen is fed to the biomass, biogas. But the biogas generator operates between 6 to 9 o'clock, about 3 hours, where you have a peak load. All lights and street lights, everything work, because there is but after 9 o'clock, these villages go for go to sleep bed. So only night time is a community lighting. That community lighting is, again, we will switch off the biogas plant, biogas generator, and then we again take the electricity from the battery. The street lights are from the battery. So therefore, there is a load profile. How it is, again, control system plays a major role. Whether the control system will take battery or direct solar or biogas generator. These three sources are integrated by a control system to the given load applications. So again, it's challenging how to integrate and which load is prioritized, whether to take, suppose in daytime you have a higher load conditions, whether to take load from the solar or battery or the biogas, because the biogas generator, it switches on automatically. When the load goes down, it switches on and makes up the load conditions. So that way it is integrated, but they are not equal sizes. Though I have explained in detail, but they are not equal. So your question is whether they are equal or not.
So thank you, sir. One more question regarding the solar tracking system. It was electronic based or the mechanical based?
Solar system?
Sorry, the
voice is breaking.
Voice is breaking, actually.
Hello, sir. I am asking regarding the tracking of the solar panel. As the direction changes, so the tracking system was the electronic based or mechanical based? Because this year, our students were participating in SIH. They have given one program statement for to prepare a mechanical tracking device for the solar panel.
Okay. So I will, because there are a lot of audience, I'll explain what is the tracking first. Okay. What is the purpose of tracking and what is the ET? You know that the tracking is important for tracking the sun, because whatever the surface, because the solar radiation has to be normal to the surface. So how do we, because sun is moving from east to west, so therefore you need to track the surface. So for this tracking, you need to move the system in 2 axes. So one is called elevation tracking, the other one is azimuth. And for this tracking, you need a system which is called tracker, and tracker consists of broadly 3 components. One is the sensor, the other one is drive, and the third one is the controller. So sensors, because it should sense that where is the sun's position, and it should give back the feedback to the controller, so that the controller gives the movement, gives signal to move the panel by a drive. So drive sensors are optical. Sometimes sensor are optical inclinometer position sensors. As far as the sensors are concerned, but control system is a power electronics based control system or SCADA type. Then drives. The drives are most important. The drives there are several drives. The drives can be a mechanical drive, they can be an electric motor, they can be hydraulic, there can be a pneumatic, there can be other than this, like stepper motors and all this. So now your question is, which is better, correct?
Sir, which will be correct. If my question, we can fully develop a tracking system fully based on mechanical. That we don't use any electronic device sensor. That will work only fully on mechanical element.
Okay. So only mechanical wise. Mechanical means track. I told you that it is a driver. Driver requires some power to keep the solar panel into the sun's path, isn't it? How do you make it? Even it's a mechanical means either you can go for
I mean,
gear
only
based.
for power system, for getting the power system only. We can use the electrical thing, but other stuff like sensing all those things which based on mechanical.
Okay. So mechanical, there are two types of mechanical system. Is a linear actuation. Actually the tracking system is called actuator. Actuator means you have to move up and down, isn't it? So that moving up and down, it can be a linear actuator. You can linearly push it and pull it, or you can change it in a stepwise. What happens is most of them are screw jack type. Whatever, if you say it's a mechanical, it's a screw jack. What happens is when I don't know whether you see this is one, you are tracking like that, isn't it? So if the sun is moving like that from east to that, you cannot rotate 180 degrees. Suppose if you go to east to west direction, that means it should go up to the noon and then come down after noon. So therefore you cannot continuously track the system 180 degrees. Only you will try to move only 90 degrees. What if this? I don't know whether you can see my picture. I hope you can see. If it is in the east like this, you can lift it like that to the noon and then rotate it and pull it down. Okay. So that is a general tracking system, because at noon time, the system doesn't know which side it should move. That is why we have to rotate the other side and bring it down. So mechanical system will have a problem when because you are lifting the system up till noon, and afternoon you are bringing down. So therefore it is moving once some 50% of the day against the gravity, and 50% of the time it is towards the gravity. So when you move this against the gravity, you have to raise the weight. So therefore there is a backlash in the mechanical system. Mechanical means as you move, when you have a higher load, you need to put more efforts, so it will become stiffer. When you move it downward, it will become loose. So therefore there is a backlash. Backlash means it can you in a screw jack, what happens is there is a what is the play. Because of that, there is a accuracy problem when you go for mechanical system. Sometimes it may not be very accurate if you go to mechanical system. I hope
Okay,
you understand.
thank you, sir.
Yeah.
Okay, sir.
A mechanical system is good when you don't want to go for high accuracy, and it's cheaper. If you go for low cost system, you have to go for mechanical system.
So thank you, sir. It was very nice session, and I will request please share the slide. It is very nice. You have presented in very nice manner, so that I can share to my student also.
Okay.
Hello, sir. Am I was audible?
Yes,
now
audible.
we are audible.
So I request to please share the slide with us, sir.
Sure.
No
Yes, sir. I will collect and I will share.
Okay, no problem. So these are bigger one. I'll share it. No problem.
Any further questions from participants? Otherwise, you can use the chat box.
You can type in chat box if you are unable to listen and you are unable to speak. Okay, I think if there is no more questions, I thank the audience for patient listening.
Thank you. Thank you very much, sir. So now I would like to invite Professor T. Srinivas to deliver the vote of thanks and express our gratitude to our esteemed speaker, Professor K. Srinivas Reddy.
Thank
So
you,
over
brother.
to Professor Srinivas.
Okay, thank you. Thank you, dear Professor Srinivas Reddy Garu, for your talk on solar poly generation technologies for reliable energy supply. Professor Reddy clearly elaborated the energy sustainability with examples for easy understanding. Professor explained about the concepts and applications of poly generation with thermal resources, especially solar thermal sources, which has more potential as renewable energy sources. Professor Reddy highlighted the need of novel tracking systems to minimize the parasitic power and increase the efficiency of the poly generation plant and the overall system. In an interesting topic, that's bio-CPV has been more detailed with the plant configurations, so that that is also suitable to the thermal poly generation configurations. Thank you, Professor Srinivas Reddy, for accepting our invitation and elaborating the thermal poly generation and its applications in a very nice way. And it's very thank you once again. And it's fine, sir.
Yeah, thank you very much for your invitation. And I think today is the second day, isn't it?
Yes, the second day. Today is the second day. Yesterday.
So I think now you have to long way to go. Maybe another 4 or 5 days.
Yes,
So
yes, sir.
so I wish all the participants as well as the organizers and you all the best for the rest of the program. I hope the participants will gain a good deal of material and research content from these talks. And hope they will implement in their research activities. I wish all the best. Thank you very much. And
Thank you.
bye.
Thank you, sir. Thank you, sir.
I'll sign off.
Okay.
Thank you.
Thanks.